Hi, my name's Mike. I'm going to demonstrate real quickly how to create a machine model that will work with Bobcad's Machine Simulation Pro. And there's some very specific approaches to it that I think just make it easy to do. It really doesn't take very much time to make one of these machines. You just have to know a few, I guess, basics as to how to approach it. So to start with, you have to really know your mill tool holders, because everything starts there. Just like in the real world, a machine can only take a certain kind of a holder. So you really have to model your machine the same as it would be in real life. I mean, a spindle isn't going to take both a Cat 50 and a BT 40 holder. So you have to figure out what it is that your machine uses, and then start with the holder first. So let's look at, as an example, we'll use a Cat 40 holder, and I've already modeled an ER32 arbor on that. So let's look at how it is as it's set up in Bobcad. So if you look at the holder portion is the top portion of the overall tool holder, and it's just comprised of cylinders and cones. So you can adjust these to actually match precisely whatever holder it is that you're using. And so the first step will be creating it here if it isn't already here. So in Bobcad, you need to create your holder if there isn't one that already exists that matches. We're just going to work off ones that are already here for the sake of this. And so then let's look at the arbor portion of that. And it's the part added on to the bottom here. So you've got your holder at the top and your arbor at the bottom, together creating the overall tool holder. Again, you can go down through, if one of these works that's already there, you can just go down through and you can grab all these dimensions and you can model one of these. What you need to do is you need to make a model of this. So while there will be one in here that it's going to use for collision checking and will actually show up in the machine simulation, there will also be a model of it in the model we create. And I find that you really should use both, because it helps you to be sure that you've got the right holder in there. If you actually change holders a lot, you might have to modify that a little bit, but for the most part, a lot of us use the same holders for everything, and so if that's the case, then you're going to want to create the holder in your model. So anyway, we have all this stuff here you can use to generate your tool holder, and so I've already got one ready over. So I like to model in ViaCAD, and so this would be like the typical ER32 Cat 40 holder. The upper portion would be up inside the spindle, and then the portion that's left, so if I get rid of that, the portion that's left, this is the same as what's in Bobcad. So if I go back to my mill tool holders and I go here, edit arbor, you can see that it's basically the same thing. And I pulled the dimensions right out of Bobcad to make this one. So what you need to do is, once you have this holder, and one of the things I like about ViaCAD is I'm able to just move things around really easy. Transforming is a breeze in ViaCAD. I think it's one of the best programs for that. So if you're doing quick 3D sketches of and models of things, I think ViaCAD is excellent for that. If you're doing things that are getting really complicated, then other things like SolidWorks or Fusion or whatever are a little bit more stable. But for what we're doing today, this will be perfect. So the main thing is that the top center of your tool holder needs to be the origin. And the origin of the machine is essentially, the way I look at it, is it's your home position. Now you could put that in a lot of different places, but my preference is to have it at the top of the Z-stroke, exactly the same as it is when I do this in the real world. You know, when my machine homes, the Z-axis homes to the top of the Z-stroke, and on a router you actually home to the corners. We'll create a quick machine that doesn't that homes, I think, more like a typical mill, but regardless, you want to model your machine starting at this arbor and working out so that it all lines up with the same X0, Y0, Z0. And the way Bobcad works is, once it's in the simulator, it will actually take the tool holder and the tool, and it's going to compensate for their length and push the head up anyways. So I'm just going to add, for the sake of visuals, I'm going to add a quick tool. I won't actually export this, but we'll just throw a tool on here. That tool diameter will be 12.7 millimeters, or a half an inch, and 65 millimeter protrusion. So it'd be an end mill or a router bit or whatever it is that you want to think of it as. So this is where we're starting from. Now let's look here then. And my mouse has been misbehaving today when I'm doing a video recording, so it's a little bit trying at times. But so I'm going to start with creating what we could term the spindle itself, and I'm going to make that about maybe 80 and 50. In the actual mill, this probably extends further up, and may even be a little bit larger than that, but that's close enough for now. So that's our spindle. So this is the first part of the actual machine, and if you were to do a tool change, you would pull that tool holder out, but this part would remain. In the real machine, obviously, it would have a taper, and that taper would be a cavity there, but we don't really need to do that for the sake of the simulator. Okay, so now I'm going to create the rest of the head. And I'll make this about 250 square and about 350 tall. So again, I deal mostly with routers, so it's a little different than a mill probably, but it'll still get the point across. Just gotta find my midpoint there. Sometimes this goes better than others. I'm also using a screen that is it is a lot trickier to use than I'd like, because it's a 4K monitor and I'm only using about a quarter of my screen right now, so it's very hard to see. It'll look big on the video, but it's actually quite small for me. Alright, so there would be our head. You can make it as detailed as you want. You can have, for example, on mine, and this would be the front because the x-axis is pointing the other way, so this would be the front of the mill. So for instance, some of the details you could add, my machine has a it has a micro adjusting dial, and we'll make that 65, 80 by 50. And so that's just so that I can micro adjust the height of the z-axis. But I just wanted to add that in so that I can show, you know, how you can group things for giving them a color. So let's now expand this side. I'm just going to make this bigger. By about 500. Okay, and you know, this isn't really all that realistic, but it's just for the sake of demonstration. So now I'll do another one. I made a mistake there. Let's try that again. I see it's still on my other work plane. Let's see, over 1,000. Okay, and maybe I'll even make that 1250. All right, now a base. And that I will make like that. And for the base and the column, I just want them to be one entity, so they'll be added together here. Okay, and now say 750 by 500 by 150. That'll be our y-axis. So we have our z-axis and our y-axis here. And I want it to home with the table. I suppose I'd want it to be with the table back, because you want to And that would be this way because it would be homing Y negative is I think most common. So we'll say that it comes within 75 millimeters of that edge. Again, you would have to know your real machine what exactly it does, and you want to get it right down perfect. You know, whatever it is that it does when it homes, that's what you want it to do in your simulation. I'll do another. This one will be $1250 by $550 by $150. Okay, so that is our x-axis, and I think I need to just move this over by 25. Okay, so now we have our x-axis, our y-axis, and our z-axis. Your configuration may be a little bit different, and then you just have to adjust in Bobcad as to how you set up the machine in the system. Another thing that we need to know at this point, which is for essentially your work offset, because just like in the real world, the simulator will need to work offset down to your table so that you can put your part down on the table. So basically that comes from about, well, so from the bottom of the spindle, because see, it's going to automatically offset for the holder and the tool, and so there it's intersecting. That's 550 millimeters between the spindle and the table. So basically, if you, whatever your work is, so let's say that you have 50 millimeter thick material sitting right on this table, then you need to offset the head down 500 millimeters, and then Bobcad will automatically offset it back up the height of the tool holder plus the tool. And so then essentially, if 0 is at the top of your stock, that would place the end of the bit at the top of your stock. So 550 is our number for that. Otherwise, I think we've got everything modeled that we need. I'm not going to keep the tool. I just wanted it there as a visual, so I can kind of make sure that this looks about right. So let's export these parts as STLs, and we want binaries. And so I'm going to go, I guess first I need to select. So if I want, so one of the things I can do is I can make things the same color, and I want to keep the tool holder in mind. You could opt to not have the tool holder, but in this case I want it because I want to show why I like to keep that where it makes sense. Like if you're someone who has the same tool holder all the time, but may have a couple different machines that have different tool holders. So let me export that, select it only, and so I put it into this folder here, and that'll be the tool holder STL. And so here in Bobcad it gives you the number of facets you're using. Since we're not really collision checking with these necessarily, we can add a lot of reduce the facets down to something more manageable, because the software will still make these look really nice. It doesn't need that many faces. If you were using something to collision check, then having more faces would probably provide a better collision check. But for visual stuff, it doesn't really matter so much. So hit OK. Now we're going to do, this is our z-axis, or we'll call it the spindle. We'll say spindle. And you're never really going to get less than 12 on a box. That's just what it is for a box. It's these, so cylinders, though, is where you can save some facets. So we'll call this the spindle end. In fact, maybe I'll just change the other one's name here to z-axis, and then we'll call this one spindle. Alright, and again, you can see there's a lot of facets there, a lot more than we need. So we'll just crank that up. That's good enough. Just to make sure that we didn't overwrite that other one. Yeah, we still have our files. Alright, and we'll do the column. And so when I'm saving these, they're all going to maintain their relationship to this origin. This particular software does not change the origin. Some softwares I found do that. Like if you save a portion of a file, they'll reorientate the part around an origin, almost centered on it. And that's not good. We want it to be maintaining its relationship to the origin. Otherwise it won't go together right later on. Okay, and this is the y-axis. Okay. This is the x-axis. Alright, so at this point we've saved everything we need out of our CAD software here, and we're ready to bring it into Bobcad. So the first thing that we need to do is we go to Bobcad. Let's get rid of these. I gotta make a new machine, so I'm gonna go current settings, add, and we'll call it YouTube mill. And it's a 3-axis machine, it's a milling machine, so we're good there. It's in metric, so these are millimeters per minute. We'll say 15,000 millimeters per minute feet are rapid, 10,000 millimeters per minute maximum feed, 15,000. These are more router numbers, they're just the numbers I'm familiar with, so we'll make it those. Now this is the standard way to do a 3-axis. I'm not going to get into how you do other things, but you can have the y-axis moving on the x-axis. So the x-axis in our situation is moving on the y-axis. So we start with an x-axis, and there's a y-axis on the x-axis with the workpiece transform. So the z-axis, you can see, is not in this tree here because it's a separate axis. It's moving independently of these. And our z-axis in this case has the tool in it as well. So that's the holder transform and the tool. You can configure these things differently, but this is the standard 3-axis. I haven't really had a 4-axis, so I'm not sure how you add the 4th axis to it, but I don't think it's really that hard to figure out. The main thing is, again, doing the modeling relative to all of it relative to the same origin, and having that origin make sense for the machine. So let's start adding some stuff here. So I'm going to add geometry. And it went right to the right one. So I've got tool hole, or I'm going to start with my column, because this is, I'm adding geometry to kind of the base here, and that would be the part that's not moving. So there's the column. I'm going to grab that. Then I'm going to rename it column, and I want to make it a different blue, so I'm going to change it to maybe this blue. Hit OK. Now I'm going to go to my y-axis. I'm going to add my y-axis geometry, and you can have more than one thing on each axis, and they can be different colors and stuff. So if you have a lot of different things that are all moving together, they all get added under the same thing, and you'll see that on the z-axis. So y-axis, and we'll make that blue as well. Now the x-axis will be our cast iron table, so we'll make that a dark gray. There's our x-axis STL. X-axis, and we'll make it this kind of darker gray there, and we'll give it some reflectivity. I don't exactly know what the scale is of this. I'm sure there's a reference somewhere that tells you. 5 is kind of moderately reflective. It looks kind of like metal, so that's where we'll set that. Now Z, you have to add some geometry. We'll add the z-axis first, though the order doesn't really matter. And then we'll change the color of this to, say, blue. Then we'll add the spindle. And on the spindle, we'll make that a kind of a lighter gray. And again, we'll make it reflective. So 5. And then we got one more thing to add. So we'll add our tool holder, which is kind of an optional thing, but we're going to do it. Again, the software will put a tool holder in there anyway. This just allows me to see that they're the same, and I kind of like that personally, so make that the same gray. Alright, So we're good. The last thing that we have to do is we have to now make those STLs available, because for some reason it doesn't actually take them out of the folder, and it won't remember the folder you have them in. So you have to copy them. And now that we've made a machine, so you'll go to local disk C, Bobcad cam data, then whatever version you're running, go to machine sim, and so we call it YouTube mill. So there's our folder it just created, and you can see there's nothing in it. It needs to have the STLs in there. So we add the STLs, and now it should be there. So let's change this, and it shows up here now. So now we have our, I'm not worried about the post because it's really not a real machine anyway. But let's now do our setup. So if you remember, in fact, I'm going to do the setup after so you can see the difference. Let's just create a quick toolpath. We'll do a little pocket. Alright, and pocketing. Okay, so now here it's important that you get the right tool holder. So let's this tool looks like it'll work, so we'll remove the tool holder, assign tool holder, cat 40 ER32, which is what we're using. So now we've got that in there. Turn that off. Let's leave that. And there's our pocket. So I think we should be set up, so it should come up. So let's see what happens. Alright, so there's our mill. So as I said in the earlier portion, when we're making the mill, it will compensate for this tool here. And here you can see this striping of light gray here. That's actually the model contained by the Bobcad generated tool holder. So there's a tool holder on top of a tool holder right here. The one Bobcad generates is the one that will be used for collision checking, so it needs to be there. So if you didn't have the tool holder in your model, this tool holder would still be there. And I'll show that in a little bit. But what you can see is that the head got pushed up. And the head got pushed up to compensate for the length of the tool holder and the tool. So that's the amount it got compensated up. Now remember, I said it was 550 millimeters from the spindle to the table without taking into account the tool and the tool holder. And then we have 20 millimeters of material here. So to bring this material down onto the table, you have to use work offset. And this is how you line your stuff up to your setup. So you go into your work offset. I'm going to also move it. I think that's going to move it further onto the table for me, having it go further on the Y. And then minus 530 should get us to where the bottom of the material should be on the table. And there's a lot of different ways to do this particular alignment of the machine to the part. Let's see if I got that right. Yeah, so it's on the table, but the table is, I think I moved the table the wrong way. So I've got to put a minus there. So let's go back and do that. So a minus will bring it more into the middle of the table. Okay, so now let's see how that worked out. Should put our part right where we want it in the table. So yeah, so it's more in the middle of the table now, and you can see that the workpiece is sitting on the surface of the table. So if you had a vise or something, I mean, you can use math to figure out exactly where you need to put your part to get it to simulate properly and to do collision checks and all that. So you could also have the spindle, when you do your model, all the way down on this table. It would actually be the other way around. You would be bringing the table, the column, and the x-axis, y-axis, and the column. You could raise all of those up so that they're touching the bottom of the spindle, as if the tool holder and tool are stuck in the table. And then when you first start your simulation, it'll move this up so that the tool is on the surface of the table. And so then if you further have stock and you program with the bottom of your stock is 0, or the table is 0, it would all work out by itself. You wouldn't have to use any work offsets. But I think that that's kind of the harder way to program. So I prefer to program from the top of the stock, because that always varies. You know, if I have a vise or whatever on my machine, it's going to be higher. So the bottom line is that for your digital machine here in the simulation, you still have to set it up the same as you would set it up in real life. You have to go in, and you could look at it as, when you come in here to your work offset, it's the same as when you enter a work offset at your actual machine. You know, it's the difference between machine coordinates and work coordinates. So once you know your formula, though, like distance from table to spindle, then all you have to do is do the math to figure out how high to set your work offset, and you'll know exactly where to put your Z. And then the same is true for your X and your Y. You'll know where your vise is on the table, and so you'll always be able to get it to work. So anyway, we'll run that real quick. So what if I do want to have my spindle down at the table level instead of way up here? So instead of my machine home being up here, maybe I want my model to have the spindle down there. So I'm going to do a couple of things. First, I'm going to show what it would be like without this, but also show how to reposition things around it. So first thing to know is that we're not going to move the head to the table. We're going to move the table to the head. So I'm just going to make these disappear for a minute. And then I'm going to grab a line off the center there. Like I should be getting. There we go. So it intersects with the surface. Again, Bobcad I think is just very, very intuitive in how you can do things. So I can get a nice square line there that I can now use for transforming. So I'm going to take everything except the z-axis. And I also don't really want, so I've got the column, the x-axis, and the y-axis. And I gotta add one more piece of geometry here. And so now, when I want to move these, I can just move them up. And you can see that our table is touching our spindle now. So this is the other way you can do it, where basically this sets it up so that your machine is gonna always have the tool touching the table as your 0 point. You could do the same thing if you have a vise that you always zero off of. You could model your vise on there and then set it up to be touching the vise. It really comes down to whatever is most convenient for you. So now what I'm going to do is I'm going to re-save these pieces of geometry. So that is my column. And yes. That's okay. I need to save my y-axis. And I need to save my x-axis. Now, I'm also going to eliminate the tool holder so you can see what it looks like without the tool holder in the model. So I'm going to re-save this as the tool holder, but it won't have the tool holder included. And again, I want to reduce the facets here. Okay. And I gotta go move my files. I already removed them, so now I'm going to put them back. And so it doesn't really know that you've changed them, and it doesn't really care. Bobcad, that is. And Bobcad will, it just references them. So now when I go to mill, problem is I've got my machine setup is set up different, so it's going to be way too low. It may not even like that. In fact, I'm going to just go edit that right now. So the work offset, if I have it at 0, oh, I've lost my toolpath. I forgot. I didn't save it. Alright, so let's make a toolpath. So this would allow you, because I don't have a tool holder in my model, this would be if you interchange different arbors. You could actually use any of these Cat 40 arbors and it should work fine. Like it'd be a pretty accurate simulation. For now, we'll just go through here again. And let's see what we've got. So remember, I have no offset right now. And I'm programming from the top of my part. So you may have seen this in the Bobcad mill before. The part you can see is exactly flush to the top of the surface. So again, I could change how I program. So I could go to my machine setup. There's a couple of ways you can change this. You can change the origin to the bottom. And that'll do it. And see, now it's simulating, right? So if that's how you like to program, then you can do it that way. And here you can see that even though I didn't include the arbor in my files, I've got my knob there, but I didn't put an arbor in. Now there's none of that striping because there's only one arbor, and that's the one that Bobcad generates. So you can see the Bobcad generated arbor in the spindle. And I need to recalculate. Actually pick a different bottom. There we go. It's still showing up there. That should actually be plus 10, I believe. This is not the way that I normally program. Oh, I think I need to pick the top. Now compute. So normally I work from the top of stock, so this is kind of very backwards for me, but that appears like that works. And you could see that there was a collision warning being given earlier when it was cutting into the table. So, you know, it's what the simulator is for. And there you have it. So that's another way to do it. Now, because we have a different tool holder, we can also change that. So I can put a different tool holder in now. And you'll see that it adjusts it. So this one should look a little bit different than it did before. You can see it's a new tool holder, but they always get placed at the same spot, and Bobcad will always offset for the tool holder and the tool automatically as well. So it's kind of all the same. You just want to make sure you have the one that you're actually using. So another way this could have been done is, instead of changing how you program, like you could still program from the top. If I bring the origin back to the top, but then I do a work offset of Z plus 20, which is the thickness of my material, that should do the same thing. So now I can program with the top being 0 and the bottom being below 0. And it will still generate the same result. There's a lot of different ways that you can do this, so you just kind of have to figure out what way works best and go with that. That's generally how the simulation works.